Okay, there is a question. So here I have 2 cos squared x plus 3 sine x is equal to 3, and again I want a solution where x is between 0 and 2 pi. So this time I'm going to change up the solution a little bit. So here it means that if 2 pi 360 is a solution, I do not include it because I want values less than 2 pi. But we do it in the same way. Now this one is a little bit different because you notice I have cos and sine. This is where your identities will have to come in handy. Now if I look at this one over here, cos squared x, you need to remember an identity where I can change one of the trigonometric ratios in terms of the other one. So if you remember correctly, you should remember this identity, cos squared x plus the sine squared x is equal to 1. And from here I can make cos squared x the subject of the formula. So cos squared x is equal to 1 minus sine squared x. So I hope you remember that. So what I will do is I will substitute this over here. And why do I do that? So that everything is in terms of one trigonometric ratio. Because if I just leave it as cos and sine, there isn't very much I can do. But when everything is in terms of either sine or cos, then I can have some idea of how to go about it. So here I'm going to substitute. Then instead of cos squared x, I'm going to put this, and it's in brackets because it's the whole of it. It's 1 minus sine squared x, and then plus 3 sine x is equal to 3. So I have these brackets that I should multiply, and remember, like the friends meeting, everybody must greet everybody else. So the 2 and the 1, the 2 and this one. So I get 2 minus 2 sine squared x plus 3 sine x is equal to 3. Okay, so now that I have that, let's maybe take everything to one side. Okay, or I will take everything to this side. Okay, so I have an idea why I want to do that, and the more you practice, you will see, this is why it went to that side. Okay, so I can see ahead because I've seen a lot of these questions, and the more questions you see, the more that you solve, the better you get at knowing how to navigate it. So I'm going to take everything to this side. So it's negative here. When it gets to that side, it will become positive. This one is positive. When it gets to the other side, it will be negative. This one is positive. It will become negative on that side. So I will have this. Okay, so I took everything over, and then I can just collect like terms. So here I have 3 minus 2, those are like terms, I can combine them. I have 2 sine squared x minus 3 sine x, and plus 1 is equal to 0. So now that I have this, I should be able to see that what I have is a quadratic equation. This is a quadratic equation because I have sine x, the whole thing is squared, plus 3 sine x plus 1. So to actually visualize it or to see it better, I will say let y equals to sine x. Okay, so here I don't say let x because I'm already using x over here. There's 25 other letters in the alphabet to choose from. Pick one of them, not x. So I let y is equal to this, then I substitute. You just need to remember that sine squared x, this means the same thing as sine x squared, and this will just be equal to y squared, isn't it? So when I substitute that over here, I will have 2y squared minus 3y plus 1 is equal to 0. I have a quadratic equation. We know how to solve them. The 3 methods. I can factorize, I can complete the square, or I can use the formula. This one looks like we can factorize it, so you go ahead and you factorize it. So you multiply these two, you say 2 times 1, the answer is 2. then you look at the middle term over here, it is minus 3. So I'm looking for two numbers that when I multiply them, the answer is positive 2, and when I add them, the answer is negative 3. I'm sure if you think about it, you will see that the two numbers are negative 2 and negative 1. And that is what I'll use to split that up. So I have 2y squared minus 2y minus y plus 1 is equal to 0. Okay, now that I have that, see here, this minus 2y minus y, this is still equal to minus 3y. Okay, then I factorize the first two terms. What do they have in common? 2y is a common factor, so I factorize 2y out. So I have y minus 1, and then these ones here, they have negative 1 in common, so I factorize negative 1 out. Y minus 1 is equal to 0. Now that my brackets are the same, they're common factor, I can factorize the bracket out again. And then here, what am I left with? 2y. And over here, what am I left with? Minus 1 is equal to 0. Okay, and when we solve a quadratic equation like this, we say the first bracket is equal to 0, or the second bracket is equal to 0. So this means that y is equal to 1, or y is equal to half. Now you need to remember that y was not something in the original equation, but it's something that I added for myself. So I need to unsubstitute, if you will. So I say that y should be equal to sine x. So I have sine x is equal to 1, or sine x is equal to half. So now that I have these two equations, you should be able to solve them using the steps that we did. Okay, so we continue over here. So we solve the first one, and then we will go to the second one, and then we combine our solutions. Now the first one said sine x is equal to 1. So we need to find our reference angle, our quadrants, and then combine the two. Or you could find the quadrants, the reference angle, combine the two. The order of those two steps doesn't actually matter. Okay, so I will find my reference angle theta first. So theta is equals to sine inverse of 1. So I always take a positive value. Okay, sine inverse of 1, I can do that on my calculator. And I just need to remember that my answer should be in radians, because we're asked to have a solution in radians. So I do this, sine inverse of 1 is 90. Okay, so I do that. So I will have theta is equals to 90, not 90, so it's pi over 2 radians. Okay, so now that I know what my reference angle is, I need to remember 90 is special. So I need to, 90 is on the border, so I need to check the other border angles and see if any of them give me 1 when I take sine of them. So 90, let's see, what about sine of 180? Sine of 180 is 0. No, that's not what I'm looking for. I'm looking for a border angle that gives me sine is equal to 1. So let us try the next border. Sine of 270. This is minus 1, not what I'm looking for. Sine of 360 is 0. So the only answer that gives me a sine value which is equal to 1 is 90. So this one has only one solution. So here, because 90, I cannot put it into the other quadrants, it is on the border. All I can do is check the other border angles. I check sine of 0, it's 0. Sine of 90 or pi over 2, that is the solution. And then I check sine of 180. That also gave me 0, not what I'm looking for. Then I looked at sine of 270, gave me minus 1, and then sine of 360. And all my border angles, only pi over 2 radians was the solution. Okay, So that's the first part. Then I have to look at the second part. The second part said sine x is equal to a half. Okay, so sine x is equal to a half. What I need to do is find my reference angle. So theta here is equals to sine inverse of a half. Again, this one just do on your calculator. So sine inverse of half okay, and you get 30. But remember, your angle must be in radians, so 30 degrees, this is equals to pi over 6 radians. Okay, now that I know what my reference angle is, I need to look at my quadrants. So this angle, or this value here, is positive. So I ask myself, in what quadrants is sine positive? And it is positive in the first quadrant, where all the trigonometric ratios are positive, and it is also positive in the second quadrant, okay, where only sine is positive. Now we need to remember what x is depending on the reference angle and in the quadrant. Now in the first quadrant, x is just equal to my reference angle theta, and in the second quadrant, x is equals to pi minus theta. Okay, so that is the definition. In the first quadrant, x is equal to theta. In the second quadrant, x is equal to pi minus theta. In the third quadrant, x is equals to pi plus theta. And in the fourth quadrant, x is equal to 2 pi minus theta. But I'm only interested in the first and the second quadrant, where where sine is positive. So here, if x is equal to theta, it means that x is equal to pi over 6. And if x is equals to pi minus theta, then it's pi minus pi over 6. And again, this we can just do it on our calculators. So we have pi minus pi over 6, and hope you can see that it is 5 pi over 6. So this is 5 pi over 6. So I have all my solutions. Now the only thing I need to do is list them. So I will say x is equal to, and we say please list them in order from the smallest one to the biggest one. It doesn't really matter how you list them. It's just easier for anybody who's marking your paper to see, okay, so this is the smallest one in the increasing order. Okay, so it's a good thing to do. Just list them in order. So the smallest one we have is over here. It is pi over 6. So I write that one down first. Then the next one we have is pi over 2. And then the last one we have is 5 pi over 6. Okay, and just like that, those are my solutions. So you see, this one is a little bit different, where we have only 3 solutions, whereas the other ones we've been solving, we'd have 4 solutions. But that is fine. It's possible to have something like that.